Hello world and welcome to the second part of the tutorial, and we just got this for a while, and this is where we stopped during the last time. Actually, this yeah this is where we stopped last time, and today we are going to continue from there. Today we are going to talk about three things. We're going to talk about scene or camera and a render. So first of all, mistake. What is a scene? So think of it like a scene is a place that we place all of our objects and we want to be seen. We place it in a scene. It can be a mesh, like a 3D object, like a cube or a sphere or any other 3D object. It can be a light. It can even be a camera. So anything we want to see, we put it in a scene. And etc. So a scene serves as a container for 3D objects and other components. This includes the light, the camera, the 3D shapes. It can even be a 2D, yeah, 2D shapes or 3D models, like a model of a tank. You can import a model from software like Blender. So let's go ahead and create our sign. So the scene takes no argument, so we've created our scene. So let's move on to a camera. Okay, mistake. What is a camera? So the camera serves as our eye. If you want to view anything that is placed in the scene, we use the camera to view it. So the camera is basically our eye. So so I'm actually going to explain this on using let's just see this is our scene. This is our scene. Let's see there's a circle over here. In order to view it, this is our scene. So in order to fill this circle, we need something to act as our eye that will fill this circle. So this a camera is there are actually two types of camera. There's the perspective camera and there is the orthographic camera. So this one is just basically 3D, and this one is just 2D, and you can think of it as also 2.5D. So we're actually going to discuss the 3D. We're not going to discuss this 3D is the perspective camera, and this 2D, the 2D camera is the orthographic camera. So let me just so in a perspective camera it takes three yeah, nice. Let's actually try it over. Let's create our camera. The first argument is the field of view. Our field of view is just an angle. Like, let's see, this is our camera. Excuse me. This is our eye, and if the angle is like, let's just call a 30 degree, and let's say this is like 45, look something even more larger, and let's see this like 70. Oh, looks even more like that. So this is 30 and this is 45 and this is 70. So you got the idea. The smaller it is, the more it looks even more closer, like this. So this is smaller, and bigger is, become more far like this. So let's say this is our camera. If the value is small, you can only fill a small portion of our scene in degree. 90 would, the 180 would have been something like this and this. So let's see this, like more than this one. The value we gave it is more than that, so it goes even like this. So you got the idea like that. That's just field of view. So normally you will find within the range of, I think, 30 to 80. Actually 90 is a very 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 bad idea, so I won't recommend putting in the value of 90 over here. So let's go with 75, and the second argument is the width of our canvas, basically our renderer. But I'm actually going to explain this later on because we get to renderer later on. So the width of our renderer divided by the height, this is known as the aspect ratio between the width and the height. So since our renderer will take up the full window width and the full window height, we're going to use the window dot inner width, window dot inner height. So the last two values are the near and far clipping planes. So basically it is telling your camera that only few objects or models or anything that in your scene within this range, any models that is within this range should be filled. If they are out of this range, they shouldn't be filled. So the first value over that's the near clipping plane. So any object that is placed below the 0.1 won't be rendered or won't be seen by our camera. Our camera won't display it because that's our near clipping plane, and the 1000 means that if an object is far, like is placed in a scene that is not 1000 or below, won't be rendered. So I think I should explain it right here. So let's say this our scene. I see this is an object, this is a circle, all of these are circle. This one is in a position of 0.001, and this one is in a position of 200, and this is in a position of 1001. Basically, if our near and far clipping plane of the camera is set within this 0.1 and 1000, these objects won't be rendered, including this. So only this will be rendered. So you got the idea. Actually, if you are tempted to set it like 1, you can still, it's still a reasonable near clipping plane, but we are going to use 0.1 for this tutorial. So you can use any value you want, but be aware that if these are much, that means our camera is rendering too much at a time, and this can slow down our frame rate, and we don't want that. So there is actually a field value that we are not going to talk about in this tutorial. Maybe in future tutorial we will talk about it. So let's move on to the renderer. So we've got our scene that we can place all our 3D objects and 2D objects, so on like that, and we've got our camera. So we actually need to render all of this onto a canvas. You can remember that when we discuss the Canvas API will say that ThreeJS is the JavaScript library for creating 3D content on the web, and where 3JS actually uses Canvas WebGL underneath the hood. So if we are going to render everything onto our canvas, we need the renderer, and 3JS provides some other renderer, but we are going to use the WebGL renderer. This can take some value, like an object. So for example, we can pass in the anti-alias, can set it to true for anti-aliasing. For those of us we know that if we want some more smooth shapes or something like that, we can set the anti-alias to true. But we're actually not going to need this. What I actually want to explain most is that the canvas, this object is going to equal to if we want to provide a canvas for our renderer, or we don't, because 3JS also provide a canvas automatically. But if you don't want to use that, if you want to use our canvas, you can easily give it a value of our canvas, like get element by id the canvas. So we can go ahead in our HTML and create the canvas, give it an ID that matches with this ID, is the canvas, and that's it. So we're actually not going to need this. I'm just saying if you want to use that. For this tutorial, we're not going to use it. So let's also go ahead and play this. So there are some basic properties and methods that the renderer provides. For example, we can set our size with the set size method, which takes in the width and the height. You can remember that this width and height, we've already given it to our aspect ratio, the camera aspect ratio. So we've already decided that our canvas width will be the window dot inner width, and our canvas height will be window dot inner height, the height of the window and the width of the window. So we can set in the background of our canvas using the set clear color. I'm going to pass in a hexadecimal value of no red, full green, and no blue. That's the green color. So actually also going to okay, let's try and run our code for now, and let's see what happens. Okay, we're actually not seeing anything, so we're not seeing our green canvas. So what exactly is going on? You can remember that when we are passing our argument over here, we didn't pass in the canvas. So currently there is no canvas. So but 3JS provides us with a canvas with the DOM elements. So these are canvas. This is what we are going to be using. we need to append it to the web page. Nice. So if we still go back to our program and let's try to run it, we are actually still not going to see anything. So what exactly is going on and why are we seeing this? So we've got our scene, we got our camera, we got our renderer, but now we are actually only using the renderer. One way or the other, we need to render the scene with our camera. Like we always need it. We always need a scene and the camera for our renderer to take effect on the web page. So going to render the scene, text in the scene and the camera. So let's go to back to our web page, and we've got our canvas and we are using the WebGL, so we can create any 3D shapes easily using the 3D primitive that ThreeJS provide. So let's actually change the background. We don't want the green background. Let's change it. Let's change it to this. And nice. Okay, now let's go back to our CSS, our style type, and let's look at the body selector that we are using over here, and let's just delete it, and let's see what happens to our program. We can see all these scroll bars. We don't usually want this. In fact, we don't want this at all. So that's why we set the margin of our body to 0. So let's just do it again. Nice. Interesting. So in order to better see what I'm discussing about earlier, we can go to the more tools, the developer tools, and we can inspect our page. You can see the canvas. Like ThreeJS actually provides a canvas to us, the canvas that we are appending to the page over here. Like here. So this is the canvas. So before we end this tutorial, actually we are going to create a cube, and I won't explain this for now, but I will explain it later. First of all, we need to set the camera position, the X position of the camera, the Z actually. You need to set it to 10, and seriously, I'm going to explain it, but I will explain it in the next tutorial. Okay. What exactly is going on? We are not seeing anything. should be seeing our box. So why? The reason is because we are adding the box to, okay, I actually said I'll explain it later, but you should notice this scene.add box over here, and this over here, and we've already taken our scene into account over here. So this new scene with our box included is not taken into account for us. So we need to, one way or the other, render our scene on our camera after we've add the box. So let's view it now, and you should see our box. Actually, it looks a lot like 2D now, but we're actually going to explain all of this in the next tutorial. And so then